Hi. Guys, when we're starting the rest of this week, probably end up having our test over this unit probably either at the end of this week or the beginning of next week. So it's coming up fairly soon. It's kind of a short unit. Now, on Friday, we went over the Pythagorean theorem. We spent Thursday going over the Pythagorean theorem as well. And I'm with you guys. You know, pretty much the majority of the way through geometry, the trig unit is actually one of those units that is probably the most important unit out of the entire textbook. Because it's the one that people use all the time. Even if they don't realize they're using it, it's being used everywhere. If you ever want to go into electronics, and there's tons of trig in electronics, and a lot of times you're not having to do with mathematics type of trig, but it's still trigonometry. So this is something that's just really kind of useful. We look at the way that a lot of construction is done. It's pretty much done with two angles. Or I guess really two types of triangles. It's either done with a 30, 60, 90 triangle or a 45, 45, 90 triangle. Those are basically the top two triangles. And what's cool about that, and I'll notice the title for today's lesson is Special Right Triangles. These are two very unique types of triangles. And this is where you can use trig if you want to, but you don't have to. All you have to know is the model, and then we start plugging stuff in. So it's kind of the nice side of this. So let's start off. We're going to first talk about the 45, 45, 90. So here it is. Now, based on the 45, 45, what does that tell you? There's a lot of stuff that tells you. Canyon?
The size of the 90-degree angle is congruent.
Why?
Because of the each angle points to a side, and the side is what equal.
Why do they equal?
Because the angles are all equal.
So what type of triangle does that make that? If my two angles right here are congruent, what type of triangle is that? It's isosceles. In an isosceles triangle, we know that our two sides are the same. So let's call that x. We'll call this x. So in a 45, 45, the two sides are always going to be the same. So then what's the length of that hypotenuse? Well, it's actually really simple.
90.
Well, it's opposite of the 90. The hypotenuse is simply the side length times radical 2. Every single time. Nope. The square root of radical 2. Or the square root of 2. Okay. Every single time this works with a 45, 45, 90. Every time. It's whatever the side length is times root 2. Every time. Let's take a look at an example. We'll look at number 1. What's my side length? 8. So what does that make this side length? What does that make the hypotenuse? 8 radical 2. And we're done. Don't need to do what? Now, I know a lot of students tend to like, man, I don't like these, they're kind of weird. It's actually a lot easier. All you have to do is look at one side length and you're done. So 8 radical 2. In fact, let's try another one. Let's get the right shape up here. Okay, let's say that this one is 3. What does that make my hypotenuse?
3 radical.
3 radical 2. Okay, so now think about that. So going and then looking at this example. Notice you don't have the side length, but the 45, 45, 90. What's your hypotenuse?
3.
3 radical 2. So what does that make my side length?
3.
3, right? Because it's basically just divide by radical 2 and we're done. That's hard?
No.
No, of course not. Until we do this.
Oh, geez.
3 rad 2 still 3.
Okay, what type of triangle do we have here?
A right triangle.
What type of right triangle?
Still 45.
It's an isosceles right triangle, which means that it's a
45.
45, 45. Now, we already said, let's go back to the model. Kind of weird here, because notice, what's your side length?
3.
No. Your side length is 3 root 2.
3 rad.
Okay, now let's go back. Let's go back to our model. Notice that in the model, whatever my side length was, the hypotenuse is the side length times radical 2. Every time. You guys remember me saying that? Every time. No matter what the side length is, the hypotenuse is the side length times radical 2. Every time. Right, Sam? So, if we go back to that problem, and I want to solve for x, well, that's 3 root 2. It's killing me here a second. So how do I find my hypotenuse? Close. 3 radical 4 is somewhat correct. Guys, remember the hypotenuse in this case, which is our x, is the side length, 3 root 2, times what? Another radical 2. Well, what's root 2 times root 2? What's the square root of 4? 2. So what's 3 times 2?
6.
Ta-da!
So can you just multiply them?
What do you mean multiply them?
3 times 2.
No. In this case, it would have been really easy since it was 3 root 2, but what if that was 3 root 5?
That would not have worked.
There you go. Okay. Yes, Cheyenne.
So, if you have like 2 different square roots
Mhm.
and you have different numbers, you can't multiply them.
When you can multiply them, but you can't add them. Alright, so you're going to have root 2 times root 2, you're going to root 4. If that had been 3 root 5, and I multiply by root 2, that would have given me 3 root 10. Okay, so you can multiply radicals, we just can't add them. Now guys, look at number 4. What do we have at number 4?
Well, you got the special triangle, obviously.
Okay,
But you know your hypotenuse.
this time I know the hypotenuse, which is similar to number 2, right? On number 2, we were given the hypotenuse. You guys told me the side length was 3. How'd you figure that out that fast?
Because it's 3 times rad.
Yeah, you just ignore the radical 2, and we're left with 3. Oh, we have a slight problem here on number 4.
It's not.
There's no radical 2. The radical 2 is embedded inside the 18. So I want to make sure we get this straight. Remember, we said that the hypotenuse of 45, 45, 90 is the side length times root 2. So how would I solve for my side length?
Divide it.
Divide by root 2. So whatever my hypotenuse is, I just divide it by radical 2, and I'm left with my value of x.
But how would you?
Well, let's start off with this particular problem. So we have 18, so we know that 18 is side length x times root 2. So how would I solve for x? Divide by root 2. And these will cancel out. So x is 18 divided by root 2. Now guys, this should be raising some red flags for you. This is something we discussed very early on in the course.
Square roots
There's a
don't go on
square.
Square roots don't go on the bottom. So how do we get rid of them?
the- You put it on the top and you keep the 2.
Yes. So that becomes 18 root 2 all over
2.
2. Can I simplify that fraction?
Yeah.
By doing what?
Dividing it by
What do you mean by it, Sam?
18.
Yeah, take the 18, we divide by 2, which is 9 root 2, and that's your answer.
Okay, so question.
Mm-hmm.
Could you just, right off the bat, take 18 divided by 2?
No.
Or would it just work with this one?
What you would have to say, if you really want to know what you do, in this particular case, if I was to overgeneralize this, and I'm not a big fan of doing this, John, as a math teacher, I'm not a big fan of teaching you this is what you do in this case. I want you to know how to do things in every case. In a particular case where you have a 45, 45, 90, and you have the hypotenuse length, and you want to find the side length, take half of the hypotenuse and multiply by radical 2.
Okay.
And that will work every time. And that's because you're dividing by root 2. So remember, we took 18, and we're really multiplying 18 by is root 2 over 2. So you're taking half the hypotenuse and then multiplying by root 2. Chris?
Well, what's odd number doesn't have to be half.
Ah, so what if it's an odd number? Well, let's say it was 11. 11 root 2 over 2. And that would be your final answer. That's a great question, Chris. Yeah, leave just in fractional form. All right, so that's 45, 45. Yay! All right, now we have one more to look at.